For those that are already here, we have got 2 basis points available this evening. So if you want to put your number and name in the chat, I can get that sorted for you after this. So yeah, do that, because otherwise, you know how it is, you get to the end of May and sort of panicking. I think we should just slowly start this going, and then people can join when they can. So thank you for joining us today. Firstly, on a slightly sad note, Tim Parton is unable to join us this evening due to an accident that he was involved with yesterday. He's completely well, and we wish him a speedy recovery. We'll get him back here at some point in the near future when he's feeling a bit more sort of tip-top condition. He was sort of determined to still come on, but we thought it would be best for him to have a rest. Few sort of housekeeping points. Please interact, jump in, ask questions. If you'd rather put any questions in the chat, that's completely fine. We can come around and ask those, as and when we see them. But it'd be great to sort of have this, as an active conversation. That's the aim of the game. For those that have just joined, we do have basis points, so please put your name and numbers in the chat, and I will get that all sorted for you after this. We are recording, and this is available to sort of watch back to those that have immediately signed up within the next sort of month on YouTube. You will get an email link to you. Going to try and keep this on time, but if we're having a good conversation, then I'm keen to not sort of cut that too short. So if you have to drop off at any point, that's not a problem. We have the replacement for Tim Parton, I should have said, is Tim Ashley, an independent agronomist, but also part-time for Edifos. So he'll be doing all of his experience. So that'll be fantastic. So let's get started. So this is a rough sort of agenda. We're going to have a friendly farmer focus from Paddy Dixon. The industry standard, rediscovering sea drenches, different methods, some plans here from Danny Sherlock, and Tim Ashley at the end to talk about sort of on-farm practicalities and what he's learned over the years of doing this. So very briefly, I mean, don't have a huge amount to sort of say in this one, apart from the obvious. After a few sort of spade casualties, we have finally had some rain. The north have had sort of 50 mil, as far as I understand. I'm in the Oxfordshire area, and we've only had sort of 10 mil. Seems to be sort of very varied across the country. Cover crops and everything are planted at the beginning, but have we really had enough moisture yet? I'm not so sure. I think for me, it was just enough for sort of things to bounce right back off again. Harvest results are back. From the autumn stampede as they are sort of donning it. Yields have been so varied, and there doesn't seem to be much sort of correlation. Yields are coming back different field to field, it seems. So maybe you're looking to sort of try something different for the next crops going in. So I'm going to hand over to Paddy Dixon to sort of hear what he's done this year and what's gone well and what's not gone well. Although having a look at the attendance sheets, Paddy doesn't seem to be here just yet. So instead what we're going to do is we'll jump straight on to Danny, if that's okay, and we'll come back to Paddy at the end. So getting the seed off to the start isn't exactly a new idea, but there has been a fair amount of evolution in both the parameters and the equipment on farm that we use to do this. So sort of without pigeonholing the industry sort of too much with sort of these trendy terms, let's look into sort of the conventional side of seed dressings, please, Danny.
Yeah, okay, so conventional seed dressing, generally it's been used with insecticides and fungicides. So common insecticide, the neonicotinoids, as we all remember, but now banned. But there's still a lot of fungicide dressings happening. But what I have noticed over probably the last 10 years or so is a lot of people staying away from seed dressings and not having a dressing. And then also lots of people reporting that they see improved vigour of the seed coming out of the ground, moving on with that. On to the next slide, please, Olivia. But yeah, there could be a couple of reasons for that. And one of them is endophyte disruption. So I'll go into endophytes in a minute, which is all in the seed. And then the other thing can be the soil resilience. So soils bouncing back better with biology by not using chemicals in the soil. Next slide. So endophytes, basically microbes like bacteria and fungi that live inside plants, but they start off inside the seeds already. And they will carry on with supporting that seed for germination and getting the roots going. There's been a lot of development on these over the years, particularly where I come from, like Australia, New Zealand, on grassland, where they have developed novel endophytes. And these are they've been selected for their ability to sort of deter insects, beetles in particular, but also help with stop grazing, because some of the standard endophytes can be quite strong and deter grazing. But yeah, they've improved a lot of those, and they now have specific ones for those in grass. But the endophytes, they've got four main functions, and one of those is like disease protection itself. And then the other one is enhanced germination and vigor. So again, could be why people see that when they don't use a chemical treatment. Endophytes can also mobilize nutrients, so like fix nitrogen, solubilize phosphorus in the soil as well. So this is all for the benefit of the plant. So releasing these triggers into the soil to get the return back for plant growth. And then, yeah, furthering on from that is the root system development, which all plays into that. But this helps really extend all the root network, get it going. So that, yeah, the disruptions that the seed treatments can do will be towards these endophytes. And so once you disrupt these endophytes on the seed, then that sets you up for pulling all these systems down, and you won't have all these benefits that the seed already has inside it. And then the other one going on from that is, if you keep adding these pesticides to the soil, you're having an effect on the soil biology as well. Next slide, please. So as many of you are aware, but the benefits of early nutrition, like the first 6 weeks of a plant's life, is generally the most important and sets it up for the yield at the end. But we want to get nutrition into the plant as soon as possible. And we can benefit the endophytes. So instead of antagonizing them with pesticides, we can benefit them and work with them. And we can do that with adding the right nutrients and adding biostimulants as well. Anything that will benefit them to keep establishing this root network, get it going quickly. Can also improve stress tolerance, so tolerance to drought if it dries out, or cold soils as well. And also improve nitrogen use efficiency once you get that network of roots going. Next slide.
So there are a few different sort of methods of feeding the seed, and it really depends on really what works best for you and what fits the farm system. So again, sort of Danny, take it away from here. But actually, before I move on, I'm curious to hear your point of view, Danny. Do you still have many farmers that you work with that use sort of the conventional seed dressings, or is it more of the nutritional side of
No.
things? Because I still have fair amount of people that use the conventional side of things, and
Yeah,
really, I was
yeah.
just curious to see what your sort of thoughts on.
I think, yeah, generally in the conventional world, there's still a lot of it used, obviously, because things like fusarium and take all, and also people that are doing second and third wheats where the disease pressure is much higher, well, that they will be using those treatments. But yeah, I generally have, I would say the majority of my customers now would not use a pesticide seed treatment, and many of them are adding nutrition down the drill or soon after.
Yeah, it's one of those things people sort of ask whether or not they should or shouldn't be doing it, and it's a difficult conversation because can't really be making those sort of decisions on farm. But anyway, let's move on to diversity of application.
Yeah, so yeah, there's three different types we'll go through here, and there's generally one of these will suit a particular person or farmer system. Um, the seed treatments is one way of doing this, and um, it is a very good way of getting this nutrition and stimulation into the seeds because you're directly coating the seeds. So this might be that you use it, set up a mix like what you're seeing on the screen. This might be a typical mix that you could do to coat the seed. So we've got like Citadel, which is our fermented molasses sauce, which is food for the biology. You've got Stim Excel, which is a seaweed, which also provides amino acids, sugars, nutrition. Pulsar is a great range of nutrients in there. And then Consortium is our range of bacillus bacteria, which will also help work with those endophytes and fix nitrogen and solubilize phosphorus. But these can be diluted with water, mixed up, and then the application process to the seed is probably the biggest hindrance and depends on how you can set it up. But it could be that you do it through an auger system or on a conveyor, or the other way is like in a cement mixer setup where you can add so much seed and then make up your volume to add to that and mix it. So a little bit more fiddly at the start, but once you've got that set up, then it's just running it through the drill. Next setup. So liquid applicators, which is becoming a lot more common now and seeing many of our customers using these. Also a great way because you're feeding the nutrients and stimulation down the tubes and straight into the soil furrow, right where the seed is as well. Not particularly on the seed, but in and around that root zone. So you're getting those nutrients there to again get that root network going, everything stimulated. So again, here we probably have a bit wider range of products we're getting in there. Again, we've got the molasses, Rampart, we're adding silicon into it here. So that is the start of building the cell strength. So we can helps prevent against insect attack or any other damage to the plants. And then Solstice is our phosphorus starter, Pulsar, again, a range of trace elements in there. And then BioPlus T is another biological, but this time with the trichoderma in it, which is also good for attacking things like fusarium. But we can also brew that as well if we want to increase the numbers. So this gives us quite a range that we can tank mix all this, put it into the tank, and then set off drilling with that.
Before we move on, Danny, we've got a question from Ian in the chat. Would you risk coating the seeding consortium if it's going to sit in the bag for 2 weeks? Letting the dressing in is time depending. Answer
No.
that one first, and then we'll jump on to the second question you just put in.
Okay. No, you want to be doing it fairly soon, like within a couple of days, I would say, because yeah, if you've got the food source with it, they're going to be starting to activate. So you want that activation to be going on in the soil, and that is part of the downside, I guess, in that you've got to be always on top of it, in front of it, really, for the next day's drilling.
Yeah, exactly that. Yeah. The second part of that question is, if you're considering using a silicon for cell strength, wouldn't the addition of calcium be a wise inclusion as well?
Yes, yeah, that's another good option. Yeah, calcium. Yeah, we do put that down the drill as well. Good choice.
Doing our job for us. And a comment from Richard. A couple of my clients have had this down pulsar applied by mobile seed treatment plans. Oh, that's I didn't. I mean, Richard, if
Oh
you're
yeah,
available, would you mind sort of jumping on and sort of saying that a bit further?
yeah, that's one I missed actually. Yeah, that is another option.
Hmm. Perfect. No, okay. Moving on.
Yeah, on to the next applicator. So if you can't do either of those applications, the next thing that you can do is apply with your sprayer and wait until post-emergence when crops come up with ideally 3 to 5 leaves. So you've got a bit of leaf area to hit, but you've also got soil you're concentrating onto as well. So same principles here as sort of down the drill really. On this mix, we've also got the fish hydrolysate, which is adding in more amino acids and sugars and nutrition there as well. And then the picture on the right there is just showing treated versus untreated with the biology and the nurturants and other food source. So there we've increased the weight, fresh weight, and surprisingly those bricks are really strong as well. Like 21's a really good number to get there. It's a good result.
Sorry, Richard, I hadn't realised that the settings were set up to be muted. I have just allowed everyone to be able to unmute themselves if they'd like to ask any questions. So, Richard, would you mind sort of jumping back to say, about your mobile seed treatment?
Yeah, a couple of people one dressed barley, one dressed some wheat. They were sort of new to the concept of, well, not new to the concept of not having the seed not treated. That's, they've been doing that for a while, but the idea of putting something on the seed to encourage the biological activity, short of actually putting consortium or bi plus T or something on, because they were a bit nervous about how long they'd be keeping the seed in the bag. But we thought it's almost a copy of actually a product produced by a multinational pesticide seed dressing manufacturer. Basically, something to feed the biology and some nutrition. This is inspired by that idea, basically, and I mean, it costs less than £5 a ton to do it.
Yeah.
So that's what there was the thinking, that the citadel would be on the seed to attract and feed the biology in those early few days, and then the pulsar would provide a bit of phosphorus, a bit of zinc, and a few other bits and pieces, just a small amount of targeted nutrition in the early days. It's the first time I've done it, but so we'll see what the results are. But I thought for what it costs, it's a no-brainer to try it, really.
Yeah, sounds good.
Thank you for that, Richard.
So yeah, that's the 3 applications, and then onto the oilseed rape, Olivia. So very similar, like the first lot, we've sort of been looking at cereals really, but the rape is very much a similar story, but we might just tweak the nutrients, so adding more boron in here. Also calcium, like Ian mentioned, is very good for the rape as well. The fish hydrolysate or seed to soil have actually done for rape, they've done trials on the cabbage stem flea beetle. So, but this is applying as a foliar when it just comes up. So they've got good results on deterring the flea beetle, on those early stages when it's susceptible. Next page. And then this is just a little snippet on the club root on oilseed rape, which was from down Oxfordshire way, I think. But yeah, it had club root early on, and then Nurture N and the consortium were applied to it twice, I think it was. So it didn't eradicate the club root, but what happens is it sort of stalls it, and then the plant starts sending out new roots. So where those circles are, you might be able to see there's some new fresh roots coming through. So then that allowed the crop to carry on and actually be a crop, really. So there are that, because the club root really is another microorganism disease. So by putting the beneficials there, outcompete those pathogens, it's turned it around. And then a little piece of news here we've got coming very soon. This is our new brewer setup. It's just a diagram at this stage, but traditionally we've just had the aeration system where it's putting lots of air bubbles in for brewing. So this system will be much more versatile and can be more aggressive as well. So it's pumping a lot more air through, which will come up through the center of that cylinder. But all the pipes you can see on the bottom, that it also has a water pump, so it'll be pumping the water through those pipes and creates a vortex to get the water moving. So very useful if you want to start compost tea extractions. So at the top there'll be a filter box. You can put your compost tea into that, and then start agitating that for an hour or two to bring all the biology into a solution, and then you can put it into onto your drill applicator. But yeah, very exciting. It should be good. Hopefully another week away or so, I think, Olivia.
That's it. Yes, we have sort of a limited sort of stock at the minute. Just to sort of get our feel of things. From the 31st is the target. So if you could please grab one of us if you want to have some more info, we're happy to share that. Yeah, it's a huge upgrade. I think the old, as Danny sort of alluded to, the old aerators were really just not enough of the sort of capacity and the sort of pressure that we've been putting on them more and more. Brewing used to be something we used to just do in the autumn. Now it's something that we do, the whole year through. So we had to upgrade the kit to sort of represent that. So we have got Tim Ashley up, but Paddy Dixon has just arrived. So I'm going to jump all the way back to Paddy's section. So Paddy, if you're available, can we take it away on here, please?
Yeah, no problems. I'm really sorry I was late. I got caught up in the farmyard, so I didn't arrive on time. Have you said anything about this at all, Olivia, or did you just skip?
I haven't, no. Skip straight over you.
Perfect. So I sent this info to Olivia a couple of weeks ago. Basically, throughout the season, I ran a trial growing a crop of wheat almost exclusively nutrition based with the help of Tim. It was his knowledge really that helped me guide all the decision making. I say almost exclusively nutrition based because at T0 there was some active yellow rust within some of the crop, and thus it did have half a litre of TEB at that stage, but that was the only fungicide it saw all season. And the three wheats you've got listed there, which are the nutrition-based wheat, a conventional Fitzroy, which was the same variety, and then some Bamford grown conventionally. Those were my three best wheats on the farm. We didn't have a particularly special year. Wheat yields were down almost 30%. But the nutrition wheat was my best wheat grown of the year. The figures are all there in front of you. If anyone has any questions about any of it, feel free to sort of ask away and I'll answer any questions. But it was grown with just the Teb at T0, no PGRs, 150 kilos of granular nitrogen plus 1 foliar, versus sort of the other two were between 180 and 220. The 180 plus a foliar, and then the 220 was all granular. And to be honest, for me, it really opened my eyes to what can be achieved with balanced nutrition. I've read about it, I've heard about it, but seeing with your own eyes is believing, I think. And yeah, I was very grateful for all the help Tim gave me, and it was fascinating to see it. Yeah, I have literally nothing negative to say about it at all. It even feels so much better to do. It's so much more pleasing to go out there and know you're dealing with problems and making improvements with nutrition and biology, as opposed to spraying a fungicide on the crop. Otherwise, do you want me to talk sort of more widely about the rest of my harvest? Is that what you're going for?
Yeah, let's just talk about sort of, what went well, what didn't go well. I mean, I have quite a few sort of questions to give you as well. You've used, if I sort of remember correctly, you used quite a lot of sort of, the straights, the potassiums, the magnesiums, the calciums. Anything obviously made like a huge difference to you? Where did you start? Which was your, what led you to do this really?
What led me to do it? I think I'm interested in trying to do. I want to grow crops that I think are better for the environment, better for people, and I know what I want to achieve, but I don't have the knowledge to know how to get there. Which is where Tim helped me, and so that week there was drilled 15th of October, direct drilled behind peas. It had a foliar sort of at the 3-leaf stage. I think it was, I would have to double check to be exact, but looking back, I think it was some boron, some wood vinegar, and potentially, I want to say, some potassium silicate, but I might be wrong. And from that stage on, really, it was where it started to look different. And then throughout the whole year, from then, really, it looked the best crop.
What do you reckon to the wood vinegar? Do you like it?
I love the smell of it. It smells like barbecue sauce. But
that's what everyone says.
Yeah, it's difficult, I think, because when you like to test a fungicide product, you apply the fungicide and you measure the result and you get your answer. But I think when you're trying to do it with nutrition, it's such a much more in-depth, interlinked picture that it's very difficult to do one thing and get a positive measurable outcome. It's all sort of an intertwined system that works together. So I don't know specifically what it did for me, but I know that what I did as a whole worked very well.
I think that's the most important thing, is like all of these things. We always sort of bang on about like a sort of a systems approach, but it really is taking a step back and looking at everything and how it works together to sort of get to that end goal. I think you sort of really hit the nail on the head there. I mean, anything you're sort of changing going into next year? Anything that you sort of want to do differently?
No, not particularly. I am planning to expand the area a little bit. I read an article that said start small, don't be afraid to scale up quickly, and that's sort of where I'm going with it. That's 2 years in a row now that we've grown wheat that's had none or next to no fungicide on the field, and it's been the best wheat we've grown both years. So yeah, I'm really happy to press on with it. I appreciate we've had 2 fairly low septoria pressure years, but yeah, I'm delighted with the results, and yeah, I'm happy to carry on and sort of try and expand it.
Thanks, Paddy. We've got a question in the chat from Ian. Are those costings including stubble to stubble operations?
Sorry, can you explain exactly what you mean by stubble to stubble operations?
Ian, I have unmiked you, so if you want to speak out loud, please do if that's easier. Or hope you're a fast typer.
While you might be typing, Olivia, I do have a question for Paddy. Your straw output on these results
Yes.
is all equal across all 3 crops, even though, we've got some have had PGRs, some have had more or less nitrogen. Is that an average figure that you've applied, or was it very much, very no real difference per field? How did that come to that?
No, so I've taken an average of the wheats up across the chalk here because I probably should have put it all into squares and loaded it away to get accurate weights, but some of it went into rounds for the cattle at home, which I don't have the weights of. So I couldn't give you an accurate field by field straw summary. So I've used an average of the wheat on the farm to get the straw figure. But you're probably correct. It was a taller crop, so there potentially probably was a higher straw output to it.
Which one was the taller crop? Because that was my next follow-up question about, the difference in the crops visually throughout the season.
So the Fitzroy was the taller crop in both cases, because I think it is a taller variety, but it was tallest in the crop that had no PGRs. But the only caveat to that would be that the Bamford on the list was grazed, and that I do notice that always makes a difference at the end. It is a shorter crop.
And there was no worry with lodging, with that sort of taller Fitzroy. You weren't concerned at all. You didn't have a panic moment.
No, I didn't. My agronomist definitely did, but I didn't. I like to graze my wheat. I would have grazed it given the correct weather conditions, but it never materialised. And I sort of thought for the field I was running the trial on, in for a penny, in for a pound, I can stomach one field of flat wheat if it comes to it.
Great, thank you.
So Ian has just elaborated a bit more, Paddy. Is your costings operating? Does that include machinery costs? So drilling, spraying, ferts?
No, that is just my variable costs. And it doesn't include my pre-drilling roundup in it either, to be upfront. But otherwise, there's no machinery costs within that.
On the back of that then, sorry Paddy, just for clarity, apologies, were there more passes in the nutrition approach than there were in the conventional? Did you feel you were travelling the field more?
So I passed once more in the autumn to go on with nutrition. Other than that, I don't think there was an additional pass at any stage. If it had been nutrition plus a traditional spray program, then yes, it would have been. But because I didn't go through with a traditional spray program as well, no, I made the same number of passes.
Right, thank you.
Oh, that's great. Does anybody else have any final sort of questions for Paddy, or even not questions, just comments or any remarks or anything you've done sort of similar at your own farm or anything else?
Yeah, I'd love to take away something to try. If anyone has any suggestions about something I could do better or different, I'd be very keen to hear it.
Maybe they can mull it over and get back to you at the end, Paddy. That was lovely. Thank you so much for doing that. So I'm going to jump all the way back to the end of my presentation now to go to Tim. As I mentioned at the beginning, but for those that have joined since, unfortunately, Tim Parton was involved in an accident yesterday. He is well and recovering. But we have a replacement Tim. We have Tim Ashley instead. Tim, are you ready?
I would be if I unmuted the mic. Yes, I am. Do you want to see me? I don't suppose you want to see me. I'm probably less handsome than the other Tim. So I'm substituting. There we go. So I'll crack on. I'll ask you to push the slides forward. So next slide. So I'm standing in for Tim tonight. So as you've heard, he's had an accident but recovering well. I'm not going to give Tim's talk. That will be for another time, another place. What I'm going to do is show you some of the things that I've been experimenting with and that I've observed using seed inoculation, biologicals and stuff at the seeding, at the drilling stage. Observations and thoughts, really. There will be a little bit of science, but I promise everybody that's heard me talk before, there will be not a huge amount of that, because I've really tried to restrain myself on that. You'll be really happy to know. So, next slide. I'm going to start right at the end. So the main sort of trial I did last year was with a farm down in Worcestershire, Savannah, who was really keen to try and do something with some biologicals and stuff like that. And we did some treated seed and some liquid application, and we followed it all the way through the season. So all we did here was treat the seed and put some some biology and some biostimulants down with the drill. I'll explain exactly what we did in a next slide, but don't go next slide. And we followed it through the season. Another agronomist was walking the fields and making the recommendations. So there was no bias on my part. There was no additional Ava magic or etc. So it was very conventionally treated thereafter. These photos were taken on the 26th of June, so well into the drought. Different cameras, so yeah, one looks a bit greener, but the dressed seed, definitely greener leaves, still holding on to the green stow, hopefully still filling grains and producing yield and protein. And you can see the untreated there is definitely going off quite rapidly. And although it was somewhat sort of messy at harvest time, we got an estimated uplift of 1.2 tons. And I'm being quite sort of conservative there. I'm not trying to make claims that are a bit exaggerated. That's pretty conservative as a ton uplift. We managed, the agronomist, very conventional, very good agronomist, felt comfortable with the treated field to use one less fungicide pass, sort of circa 10-15 quid worth of fungicide saved. But other than that, everything else was the same. Very little nutrition in terms of foliar applications through the season. Next slide, thanks. So what did we do? We did a couple of things. We had one whole field, so it's a farm scale trial, one whole field. Half of it was we had some drenched seed. I'm not sure whether that video will play, Olivia. It might play. Yay. And you'll see my friend Robert Collins there. I think Kevin's there as well. This is a lovely little machine that set up, that Robert and Kevin have set up, where we're literally spraying on that recipe that you can see underneath there onto the seed. It's going into the bag. So we're literally coating the seed as explained by Danny and stuff. There's the recipe. Not going to concentrate too much on the recipe, but you know, we got some carbon, we got some biostimulants with fish hydrolysate and seaweed extract. We used some consortium, neat consortium straight out of the bag. We didn't brew it up, and we made it up to about 14 litres per tonne application rate. Now, it was a little bit messy, and we did actually have to put it through the conveyor, or I say we, I didn't. Robert and Kevin put it through the conveyor twice just to get all the seed coated, so it wasn't quite so sticky. But once we did that, was a bit of a faff. it flowed through the drill really well. The other half of the field, we did exactly the same recipe, but as you can see there, we've got an AV avatar with the TT liquid applicator. So we just put that same recipe in as a liquid applicator that goes down down the slots with the drill. So the approximate cost of all of that was £43 a tonne, which works out at about £8 a hectare. I say non-brewed because we used neat consortium. If you brewed up the consortium, dead easy to do, you'd make that even cheaper. So I've just put some other costs there for comparison. So clean only is about £50-60. If you had the single purpose dressing put on your home safe seed, that'd be another £100 in total. And then if you were to buy the Gramax MP, which is Certis Belcom product, which they're putting through a lot of mobile seed dressing, they're charging about £70 a tonne there to do it. So kind of doing it yourself, making up your own recipe, using your own biology or using whatever product, you know, it's pretty cheap. Next slide, please. So we've got the three treatments there. So the untreated, by that I mean it's just single purpose dressed in the neighbouring field. We've got the liquid applicator in the middle there, and then we've got the dress seed that's gone through the conveyor on the right there. Not a huge visual difference, but this is literally only 2 weeks after drilling, and you can start to see the riser sheath forming on the treated seed. You can start to see there's a little bit more biomass in the roots of both the treated seeds. Arguably, you could say that the dressed seed has a bit more leaf, greener leaf there. This is, next slide, please. This is the magic slide, if you like. This is the real money slide, I think, in terms of what this trial really showed. So 24th of April, we were digging up some plants and stuff and comparing the roots. Took the roots and washed them and had a look at them. So the untreated, I wouldn't be unhappy with those roots. That's fairly standard, decent rooting on our wheat plant. You wouldn't bat an eyelid at seeing those kind of roots. There's some quite deep roots there, so you wouldn't be overly disappointed. There's obviously no compaction really causing us any problems. Liquid applicator, definitely more bulk, more biomass in those roots, longer, more sprawling, and then you get the dress seed, which just, you know, eclipses both of the other ones by a mile. And you can think, you know, with the season that we've just had, you know, which route architecture you'd actually want this year, for sure. You know, those really deep roots, lots and lots of roots going down there, absolutely fantastic. And that literally cost us £8 and you know, a day or two's work and a bit of hassle. Okay, so that's all well and good. How did we get on? So next slide, please, Olivia. This is not a really clear photograph because I very stupidly, when I took these photographs, I realized that on the left there, the untreated is 5 plants, and on the right of the dress seed is 4 plants. So you're comparing 5 plants with 4 plants. But anyway, the headline is that on average, we were getting 3 ears. We had 3 tillers with 3 ears per plant on the untreated, the normal conventional, and we were getting 4 ears per plant on the dressed seed. So I've taken out the liquid applicator one here just to keep it simple, stupid. Yes, we can argue that those extra ears are likely to be those small ones on the end there. but they are, they are grains, and the final yield, the specific weights came out at about 76. So not.
And say that soils have a fantastic.
Is that all right? Yeah. Somebody asking a question? No.
Don't think it was Tim. Let's carry on. Yeah.
We'll have. So what's going on? Why are we doing this? What is we can see that we get really good results, or we can get visual results, we can get sort of tangible results. Yield, yes, we can get more ears, we get more better roots and stuff like that. So what's going on by just adding a bit of biology and some biostimulants onto the roots? So let's go back to real basics, and I know Danny touched on this, so I'll keep it brief. The next slide, please. So if we were to look at a wheat seed, a healthy seed isn't sterile. It's already got, doesn't matter what it is, whether we've treated it, untreated, whether it's organic, conventional, whether it's had a ton of stuff sprayed on it or nothing sprayed on it, it will have these endophytes and these epiphytes, so stuff living on the seed and stuff living in the seed. I focused here on the fungi because fungi are pathogens, can be pathogens, I should say. So this is research done by Solanke in 2021, and this is all the fungi species or genera species that he found on conventional wheat seeds. And there's dozens there, and the people with keen eyesight there will notice one or two sort of pathogens: Alternaria, Picini, the rusts, the Septoria there, there's Fusarium there, etc., etc. Vast majority of those are not pathogens. What are they doing there? What are they doing there? They are there because the plant wants them to be there. In a way, they're there because that's their habitat. So if we think, let's just focus on the pathogens, really. We don't want them on there, but they're going to be there. Why do they show their virulence or not show their virulence? Their presence doesn't mean disease. Some just live as endophytes, and some are saprophytes. They're living off, they're going to be feeding off the organic matter that's in the soil around that seed. Some are facultative pathogens, and they have very different roles, but a very sort of simple way to think about it is that some of these organisms are part of the recycling system. That once that plant has done its job, or it's got sick, it's been eaten, whatever, once it's kind of done and dusted for whatever reason, and that could be environmental, could be disease, could be competition, you need something to take it out. You need something to basically rot it down, to take out the trash. If you just think of it as just taking out the trash. So when those diseases sort of take hold of our crop, that crop is sort of signaling to us that it's unhealthy, that it's sick. And so those pathogens are sort of switched on, if you like, to show their virulence and stuff. If they're always going to be there, they're always going to be there. And so it's just a question of trying to make sure that they don't show their virulence. Next slide, please. I'm laboring the point too much. And just for completeness, rather than anything else, those are all the species of bacteria that you find in and on. So there's an incredible diversity of biology on and in the seed already, without us doing anything. It just is there because it's an ecosystem. It is a system, and that plant is using this biology to its own ends, and it is trading with this biology when it's living in the soil and growing and stuff, we're trading exudates from the plant through photosynthesis, and it's using this biology to fetch nutrients and stuff like that, which Danny's already explained. But in order then for that plant, it reproduces, it'll send some of this biology up into the seed. So when that seed goes back into the soil to germinate and go again, it's kind of got its starter kit, it's got its starter population already there waiting to get going and to get this plant and crop going. So I just wanted to highlight the diversity. Next slide, please. Why is the biology there? I'm not going to dwell too much on there. It's there to obviously help the plant feed, get food, you know, the exudates into the soil, biology responds, fetches the nutrition and feeds the plant. It helps plant extend their root system. Mycorrhizal fungi do that fantastically to help get water and nutrients, particularly phosphorus. It helps in the protection of the plant in terms of induced systemic resistance, fighting pathogens. The clubroot is a fantastic example. Bacillus is really good on fusarium, both in the soil and on the ear, etc., etc. We've got this whole communication thing going on, where we've got the biology kind of talking to each other, not literally, but sending out chemical signals. They're receiving chemical signals and stuff like that. And the plant is kind of communicating with the biology as well. And like I said, these sort of things that we call pathogens, or the fungi in particular, they're there to recycle. So we don't want, you know, our stubble to be there forever and a day. We want it to decompose, release its phosphorus and potassium, nitrogen, etc. So it's there to recycle the plant residues, if you like. Next slide, please.
Just very quickly, I'm going to jump in here. Something that I've been to quite a few of your talks over the years, Tim, and something you say every single time that really sticks with me is the idea of this positive feedback loop. It's a sort of phrase I have sort of stolen, over the last couple of years, but that really just sums up what it is we're talking about here. You know, this is about feeding back into that positive feedback loop, really. So just wanted to mention that.
Yeah. I mean, exactly. So the more we can encourage a healthy plant, the more we can encourage that plant to have a healthy microbiome, and the more kind of negative inputs that we put into the system, whether that's growth regulators, whether that's fungicides, herbicides even, you know, these things are kind of, they are negative. They might be very necessary. If we've got an outbreak of yellow rust, no amount of biology is really going to control it. We've got to go in like Paddy did, like Paddy and Tim did. You've got to put in a bit of tebuconazole. Now, tebuconazole is going to give you a bit of a kickback into, it's going to control the disease, but also has a negative feedback. But if we're kind of trying to keep moving forward all the time with positive feedbacks, that's when we start to improve the whole system, and we start to see changes over time. I'll not dwell on this one too much because, again, I've kind of already said this, but the whole point of the seed microbiome is to kind of be the starter for 10. The seed is not a sterile thing that just sits there with a bag of starch and an endosperm that sort of just magically germinates. It goes into the soil. Those conditions are wet, hopefully, moisture and dark. The biology responds to that. Those biological signals, those chemical signals, then encourage the seed to germinate, blah, 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 and all of this kind of stuff. And that really early stage, like Danny said, you know, is so critical to the seed. And so that biology is there. And then once it starts growing, we start to get this interaction with the actual soil that it's been put into. So we've got our soil biome. Now we've got our seed biome. They start to sort of meet and work together, or not, as the case may be. And we get this rhizosphere forming around the roots, where the soil kind of sticks to the roots and all of that. And as the plant is pulling in nutrition and all of that, it's actually also pulling in biology in through the roots, and you can then talk about the whole thing of rhizophagy and stuff, which we will not go into right now. But this whole thing of the plant ingesting and using biology to pull in the biology from the soil into the plant, and then it moves it around the plant and then puts it into the seed for the next generation. So it's constantly sort of recycling this kind of thing. Next slide, please. I apologize for the AI generation of these graphics, but I didn't have time to sort of, well, or the inclination to, AI is so good at doing these type of things. So it has to work within a system, like Olivia said. This is my whole thing. It wouldn't be a talk by me if I didn't start waffling on about systems and stuff like that. So just inoculating your seed does not mean you're going to get really good colonization. It does not mean that you're going to get real good function or results, if you like. It depends on the whole system in which you put it into. So what's the existing seed microbiome like? How are you looking after that plant health? Is it actually capable of sparing photosynthetic exudates to put into the soil? Is it just kind of coping with just growing itself? There's so much nitrogen in the soil that it's just shutting off half of these systems. Has it got enough carbon? Have we got the right kind of soil microbiome that's recycling or cycling the carbon within the soil? Have we got moisture? Hot topic. Is the nutrition there? You can read all of those things. So it has to work within the whole kind of system, and we want all of these things to be as positive as possible. If we start sort of having negative feedback, or we have weaknesses in our system, we might have really high pH soils through geology and stuff. That might cause us some problems. We're not getting the right kind of biology into in the soil. That might sort of create a bottleneck, which causes phosphate deficiencies or calcium lockup. So we need to inoculate, we need to help establish, we need to establish in good conditions, etc., etc. We need to support these plants going through their life. And in some cases, it is the case where, and you'll hear this sort of, whether on social media or whatever, oh, we tried that, it didn't work, or, well, we've been no-till for 20 years and we tried it and it didn't work. Well, in my experience, and admittedly it's relatively limited, but in my experience, you're going to have the biggest wins when your system that you're putting it in is a little bit compromised or dysfunctional. So if you've been home saving your seed, you've been working on a very regenerative system, you've been using a lot of nutrition, and the soil's really good, we've got good organic matters, the redox is really good and stuff, and then you think, oh, okay, let's try some of this biological inoculant, and you put some consortium in and you think, well, actually it didn't really do much. Well, your system is really good or functioning really well, so we're going to see less impact from that. And in that case, what we're probably going to be doing is, rather than sort of going sort of down the biological route, we might be just stimulating the biology that's already there, the seed microbiome. So we might just be putting, some seaweed extract or fish hydrolysate down the thing. And also, it's kind of why, sorry, I'm speaking very fast. It's also why I probably favor, sorry. It's also probably why I favor sort of compost extracts and stuff, because we're getting a huge amount of diversity in our composts and stuff. So we're getting all of the species, or a huge amount of the species that are in existence in our local environment into the system. So if there is any sort of bottlenecks or weaknesses or dysfunction, that sort of compost extract can hopefully fill that. Whereas if you're just using an off-the-shelf kind of brew, consortium Bi+T, which is only 5 or 6 individual species, very good species, they might not sort of give you the results that you want if your system is further down the line, if that makes sense. So as the system becomes more functional, perhaps the question changes from what biology should I add to how do I support the biology that I've already got. And this is where the sort of the compost extracts and the teas, or just using the biostimulants like seaweed extract and fish hydrolysate come into. Next slide, please. Right, that is all the science and stuff that I'm going to waffle on about. So I just wanted to give you some examples of what we've done with some farmers in the Midlands here. So this was some peas and barley companion cropping that we did in Shropshire, South Shropshire. So it was farm-made compost, sort of soil food web, Elaine Ingham style compost that we make, because I'm a big fan of that. The farmer, brilliant engineer, made his own liquid applicator to go on the Avatar drill that they'd got, and we did some liquid applications via that. Now hopefully you can see on the left hand side of that left photograph is a really nice sort of green crop, and then we've got this margin here which is looking a bit sort of pale and not so great, and obviously that didn't get the liquid application, and the rest of it did. And then you can see the individual plants there. The left of my knife is what received the inoculation, and on the right which didn't receive the inoculation. Next slide. Some oilseed rape, not as good as Danny's, full of flea beetle, absolutely getting caned there. But this was some oilseed rape, which we used some Bi+T, some seaweed, some fish hydrolysate, some nurture. I think some pulsar went in there as well, with the TT, the Trevor Taplin liquid applicator, fantastic machine. But the root rhizosphere, not brilliant photograph there, but was fantastic. But we didn't have a control, so scientifically it proves absolutely nothing. Next slide. Where are we up to? Yeah, we did some maize. I did some maize, sort of, well, a farmer did some maize experiments and stuff. Again, farm-made compost, best compost I've ever seen. And all it was he got a beef shed, which he was using wood chip as the bedding base, straw on top of that, cattle on there for 6 months, left to rot for about 2 years. Absolutely phenomenal compost. Nothing particularly scientific about it, but just made brilliant compost. We made an extract, we put in some various nutrients, and we applied it as a drench onto maize seed. Now maize seed always comes with a fungicide on it, and you can see there that it didn't really bat an eyelid with that. Untreated on the left, obviously treated on the right, much better root going there. Cotyledons, twice the size, photosynthesizing twice as much, I would imagine, and off to a flyer. What we wouldn't give for maize starting off like that this year. Next slide. So what organisms does the plant actually need, or which way should you go? You can go down the consortium, or your bugs in a jug type of thing. There's plenty out there on the market. You've got your formulated inoculant. It's selected. We've selected, or they've selected well-known species or strains of bacteria. In this case, 5-6 species, strains of bacillus. They're known. They're well researched. They are plant growth promoting bacteria. You know, they are the best ones, if you like, that do a really good job. It's repeatable, it's convenient, it's targeted. Anybody could use Consortium if they've got a liquid applicator or they want to do some seed drenching. You want to use the machine that we used at Savannah's, you know, get in touch with me. We can organise that, I'm sure, with Robert and Kevin. So that's where I would probably start if you're completely new to this. So, you know, Paddy, what would you do next? This is what I would do next. Brewing up some biology and getting this onto or next to the seed. This is by far the best thing you can do to get with biology on a crop. If you can get it into the seed, as Danny said, those first few weeks are the most critical, and you can get that relationship going between the seed, the soil, and the plant, you're off to a flyer. You know, when we were at Savannah's there, all we did was put a very small amount of Consortium, a very small amount of seaweed and stuff like that on the seed in September, and we saw the results in July. You know, nothing else changed. So biggest bang for your buck there, and that's where I'd start. If you're more intrigued, more kind of curious, making your own composts, absolutely phenomenal, really exciting, an absolute rabbit hole to dive down into. Something you can do during the winter in terms of like making your compost and stuff ready for the next year. You're going to get that huge diversity of species in there. You're going to get thousands of species in there as opposed to sort of 5 or 6. You're also going to get, I didn't write it there, but also and arguably maybe more important, that composting process, whether it's a Johnson Sue or Windrow or whatever, when that decomposition of all that organic matter is not only breeding a very diverse population of biology, it's also creating metabolites, these fantastic chemicals that are going to sit there in the compost that the plant just craves, if you like, just loves. And when you're doing this brewing process, you can see there, I don't know who this chap is. I think I just nicked it off the group chat. But, you know, you put all of this compost into a brewer or an extractor, you know, and all of that brown stuff, it's all these metabolites that this biology has made, and that's going into your crop or onto your seed as well, which is just gold dust it's a superfood for the plants. What else? It's local, so mostly you're making compost from your local environment with your local plants material. So the biology that you're making is indigenous, so it's going to fit quite nicely with the biology that's already in the soil. It's obviously very low cost in terms of materials. It's a bit more time consuming, it's a bit more faffy, there's turning and all of that kind of stuff. We can do another talk on how to make compost, no problem. You can adapt it in terms of what you do with it or how you make it. Do you make it fungally dominant? Do you make it bacterially dominant? Do you try and get more protozoas in there and stuff like that for different reasons? But the con is that you can get it quite wrong sometimes. So you can get variable results with it because it's not very consistent in terms of, you know, whether what the compost is and stuff like that. Next thingy. So what would I do? So what should we actually do? Start small. Paddy summed it up quite nicely. Start small, ramp it up quickly, but start small, you know, have a bit of a trial, whether it's a patch on a field, whether it's a field, just have a go. And you can dress seed in a bucket or a barrel. You just make up a batter with those ingredients, less water, you make up a batter, mix it with the seed. You know, you can use cement mixers, you know, you can figure it out, I'm sure. It doesn't have to be really scientific. There's a lot of people on here from Ava or myself or Edifos that can sort of guide you into making it. Just do a bit of a trial. Leave a control, please leave a control, because, you know, as Danny said, or actually what Paddy sort of alluded to, was it's really difficult to kind of, it's not like a conventional trial where you get a fungicide and you get result A and you can see, you know, we got this kind of yield uplift or whatever. It's really complex systems that you're sort of trying to influence here, and you really need to be able to see and experience the changes that you're seeing by doing these doing these things, if you like, with biology and the biostimulants. So always leave a control. Don't leave it next to the headland, because I would argue that the headland is going to get the most kind of stress, and that's where the biology is going to work better. Leave it in the middle of the field or something like that, but it's entirely up to you. Just leave a control. That's all I ask. Carry a spade. Always carry a spade and start looking at these roots, because that's where all the magic's happening. You won't see much difference in terms of the canopies and stuff. We're not doing nitrogen trials here. We're not doing fungicide trials here. We're doing biological trials, if you like, and this is all to do with the roots and the interaction of the biology and the soil. And it's that system that we're trying to just manipulate, if you like, that system that we're just trying to sort of ramp up a bit, so you can see the differences in the roots. This is Savannah's trial in the middle there with the this is before I washed off the roots. You know, you can see the color of the soil, you can see the root, the root mass there, the root bulb there. It's just phenomenally different. So seeing that just gives you the confidence to know, right, I'm doing something right here. And then follow it to harvest. You know, if you can combine it or harvest it and get some yield data off it and some quality data, you know, what's the protein like, what the nutrients in the grain like, and stuff. And that, you know, we did that at Savannah for £8 a hectare. We got a conservative £1, 1 ton per hectare uplift for eight quid. And, you know, not really pushing any particular products, they're just principles. So as I always end my talks, you know, biology is the answer. So, you know, what's your question? And there's my details. Thank you.
That was brilliant, Tim. Thank you for all of that. Does anybody have any questions at all? I have two that I've been mulling over in the back of my mind since you've been talking, Tim. The question that I sort of keep getting asked at the minute is, obviously moisture is scarce at the minute. So do we just assume that all of our biology is either dead or dormant, or, you know, what's the idea here? What are we looking at going into the autumn?
Okay, so yeah, it's going to be dead or dormant pretty much, but it will come back. It always does. Just look at the natural environment. You know, it will come back, and it will come back remarkably quickly. The biology is kind of there. The DNA is there, particularly from bacteria point of view. The spores, fungi will go into spores, and it'll just sit there, and for years and years and years and years and years and years and years. You know, they're pretty indestructible. So, you know, don't worry about that. You know, we need moisture for these things to actually work, respire, and to live and breathe. So what would I be doing? I'd be, you know, I think this would be a really good year to actually try some of these inoculants, whether that's with compost, you know, or with a product like Consortium. It would be a really good year, because I think it's going to be a slow start in terms of like the soils coming back to life. there's going to be plenty of nitrogen in those soils, and we kind of want to get access to that nitrogen while the soils are still warm. And if we're going to go into this sort of El Nino mega wet autumn, which is kind of worrying, isn't it? I want to get those crops established and going and getting the roots there so they can, and the rhizosphere there. So, I'm trying to get catch crops in, I'm trying to get cover crops in. We can kind of use some of this theory to sort of prime the soil. So, we can't get a cover crop in, or it just doesn't, we don't get enough moisture to sort of put a catch crop in, in front of wheat this autumn, but we get a bit of moisture. We could use some of this biology or biostimulant type of stuff. I like the idea of putting in, a carbon source, whether that's Citadel, something quite sugary would be good. Some fish hydrolysate, some seaweed extract, get that onto the soil at planting or just before planting. And then I'll just get the soil a bit excited, provided there's moisture there. Get the soil, and that's just kind of like a primer. And I've started to do that now, and I will definitely be doing that this year on a pro. Don't get me wrong, living roots, 100% the best thing. But if I can't get living roots going because I'm running out of time because there's no moisture, then that sort of soil primer would be the next best thing. What we're just doing is mimicking, sort of banging in those exudates and getting the biology sort of up and running. Because, the biology is kind of sitting there dormant. Yes, there's going to be some moisture coming, hopefully soon, but it's got no food as such. So we just want to get them fed and watered. And
yeah, thank you, Tim. That was really good. We've got an interesting question from Ian in the chat. So how does biology mitigate against YR15 in wheat? Do we have an answer for that?
Sorry, I missed that.
Sorry, how does biology mitigate against YR15 in wheat?
It doesn't. I
There
mean,
you go.
I mean, I did some blends this year with which included several varieties with the YR15 gene, which is my kind of like moment of 2026 or 25, never to be repeated. But it's not, you don't know about these bloody genes until sodding stuff's in the ground. If you excuse my language. But what I think we all can agree, whether you're agronomists or farmers, you'll have some farms where the yellow rust just absolutely rips through a particular variety. And then you'll have a next door farm where the variety is relatively unscathed or has minor infection. And how a pathogen will express itself will basically depend on how sick it thinks that crop is. Now, genetic weaknesses with the YR15 and the strains of yellow rust that it was able to sort of infect those variants, you've got a very, very weak variety there. So it doesn't take much weakness or much stress, shall I say, for that disease to express itself. And, I could show you photos of overlaps with Broadway Star, and that overlap, the yellow rust just absolutely obliterated that blend, whereas either side where it only had the correct dose of Broadway Star was relatively mild. So how do we mitigate against that? We can mitigate against that by creating the healthiest plant we possibly can. So the seed drenches, all of those things, that sort of root architecture, that sort of root reach, that healthy microbiome will enable the plant to be as unstressed as possible. we can help it by doing some sap analysis and doing some foliar feeds to sort of help that plant out through particular issues, whether that's manganese or boron or silicon or something like that. But we can't, once we've got that sort of genetic weakness in a variety. I'm sort of overgoing here, but you get the point.
That's perfect. So Gemma has said, can you do that compost seminar, please, Tim? We will be having our next seminar is all things brewing. So if Tim is keen, maybe we can get him back to do a compost tea / extract sort of seminar. But we could discuss that off of here, Tim. But maybe that could be an option.
Yep.
Into the next question. I'll take this as the last one, unless anybody else has anything else to throw in the chat now. But this is from Dan. Are you looking into hydrogels as a solution to hold onto the moisture for longer, given that the last 2 seasons have been droughts? If so, what have you found? Any thoughts on that?
Hydrogel, no. But I tell you what we are doing, and this will be music to somebody's ears on this chat. We're looking into sort of biochar and trying to do that in a big way to kind of see where the sort of economic benefits or the economic sort of balances of using biochar and encompassing, not biochar on its own, but loaded biochar, getting biology and this nutrition into the biochar and then using that as a vehicle and a refuge, as a hotel, if you like, as improving that environment. And I think we've still got to do a lot of work on this to kind of work out. We know if we put a huge amount of biochar onto the soil, then we can mitigate against things like drought and stuff like that, but it's kind of a bit expensive. So we're looking at things there. So anybody that's really interested in that kind of things, get in touch with me. There's various adopt projects going on. Likewise, we're doing some adopt stuff with some biology as well. So anybody that's really keen on that, on a farm scale type of thing, get in touch. See what we can work together. Hydrogels, sorry. We'll look into it though.
Maybe for a future seminar we can touch back on that, Dan. So no final questions in the chat I can see. So I'll bring the meeting to a close there. Thank you so much for joining us this evening. If you have any more questions, please reach out to myself, Danny, or Tim, and we can talk everything over again. Like I said at the beginning, this will be available on YouTube. And yeah, please do join us for our next seminar in September. I'll be getting started shortly on sort of getting that out for everyone. Maybe with Tim, maybe not. We'll see how he feels about that later on. But yes, I will bring this meeting to a close now. So have a lovely evening, everyone, and thank you again for joining us. See you later.